Let's get started here. Welcome back to another video here at Civic Innovation YouTube channel, discussing again the practical applications of generative AI for local government. I am here with one of my favorite tools, Julius. In case you didn't know that I actually like this tool a lot, I actually happen to have let's move the microphone away so you can read it here, Julius Artificial Intelligence sweatshirt on. Thanks to the folks over at Julius for sending this swag over, and to Rahul, phenomenal tool that you all built here. So excited to be able to use it, excited to play around with it and show you all what this can do. So talking about visualizations, talking about the ways that we can use this in the context of local government. And in the same way we talk about this within ChatGPT in the prior video, doing the same thing here and talking about this within Julius, and we're going to use the same data set, right? Same thing from data.gov. I think this information is still from Cary County. Let me double check to make sure. Yep, still Cary County, still Cary, North Carolina. Sorry, not Cary County, but the city of Cary, North Carolina. So we're going to pull in some information here on fire hydrants first, right? Kind of an odd, kind of random data set. Let's go ahead and play around with this. So I download it first. That way I have it already downloaded. And I'm going to say I have a data set on fire hydrants that I want to analyze from the perspective of a development services director. I'm going to upload this file here. Let's go ahead and grab my fire hydrants. Here we go. This is a pretty big data set too, so hope it doesn't get too messed up. I'm kind of worried. It's just so massive. That's why. I know Julius can handle it. I just don't want to get timed out at all. But let's go ahead and try. It's going to examine the data set by the first couple of rows. The summary here. Here we go. It's about 4,000 entries in the data set. All right, makes sense here. And let's say this is what I like about Julius, right? Is that it gives us some preset prompts. So sometimes I don't even know what to ask for. Like with these random data sets like this, I don't really have a pathway forward per se. I'm not sure what to do with it. So let's look at, could provide a breakdown of the distribution of fire hydrants across different owners or pressure zones. I can explore the age distribution of fire hydrants, identify any maintenance or replacement needs. Let's do this. This will be useful. Okay, it's going to analyze the age distribution, calculate the age of each hydrant based on the year installed in the current year. Then we'll visualize the distribution of these ages to see if there are any patterns or specific age groups that might require attention. Here's the histogram showing the age of the different fire hydrants. Okay, so it has a count about 3,900, approximately 70 years old for median age, standard deviation here. So it has a recommendation. It says data cleaning. We should address the erroneous maximum age value. Maintenance planning. Focus on older hydrants, especially those over 50 years, as they might require more frequent inspections or replacements. Let's go ahead and correct the anomalies in the age distribution and just make sure we have that all cleaned up and cleared up. Another thing I'm going to do here in a second is that there's also a field called hydrant painted, the year the hydrant was painted. And so I wonder if that's kind of a good metric to see when it was last serviced or something like that. Let's clean up this step right here. Unless folks in Cary, North Carolina, do you have hydrants that were built prior than 1900 that are 124 years old? Maybe you do. There's some historical ones. I'm not sure. Cool. So here we go. We have a little better now. And I want to say is there's a field in the data for year painted. Maybe that could be a good baseline for the last maintenance on the hydrants. Okay, it says, good idea, cool. And examine the distribution of the years in which the hydrants were last painted, calculate how long it's been since hydrant was painted, and visualize this information. Help us identify any hydrants that might need repainting or other maintenance soon. Here's the histogram showing the distribution of the years since the last painting here. Okay, again, erroneous entries in the year painted field. And let's say again, clean the data. Okay, some of the same approach with the year installed data. Use the same approach. Filter out those erroneous entries and re-examine the distribution of years since the hydrants were last painted. They clean this up now. Okay, it's been cleaned. Here's the histogram. Cool. Count, observations. So let's see here. Maintenance planning, focus on hydrants that have been painted over 30 years, as these might require more urgent maintenance. Continue to monitor and update the painting records to maintain the integrity of the data set for future analysis. So with this right here, what I want to look at is let's look at the correlation between the last painted year and the material of the fire hydrant as well too. It might be interesting to see if there's anything that's like how have hydrants changed over the last years. Let's look at this. I'm going to create a grouped visualization. It's a box plot to compare the years since last painted across different materials of the fire hydrant. This will help us to see if there's any noticeable trend or difference based on the material. Okay, there's nothing there. Let's look at here. All right, looks like we don't have that data there, which is fine. Let's go back to the drawing board. And let's say here, I want to know which geographical areas have hydrants that were installed for the longest periods of time. Hope that makes sense. I don't know if I worded that really great. Basically, I'm looking to see is which ones were installed, but then waited a long time for it to get painted. Maybe it has why would that be? Is it anything in terms of socioeconomic things or anything like that? Why some paints, some would be left unattended, and so I want to see what that looks like. Okay. Most area locations in the top 10 of hydrants that have been painted for 38 years indicate a potential area-wide issue maintenance practices. And what I want to find out too is identify the distribution of unpainted hydrants by pressure zone. I want to see if you can you map those locations out for me? I'm curious where those are, if they're kind of located similarly. Okay, looks like we have the geographical information here. Let's see what we can get. So we can do. Let's see if we get lucky here. Oh, we ran into an error. Okay, so here we're trying to make a map for us here. Ooh, okay. So it gave us a map of all the fire hydrant locations, right? But I just want to see the clusters of fire hydrants that have not been painted for a long time. Yeah, let's see this here. So it's going to look at the highlighting hydrants that have not been painted for more than the average years painted, and then use a clustering algorithm to identify any significant clusters. Cool. And I also like the fact that it's actually looking at the average, right? Because it could be like, hey, look at the last ones that were not painted the last 10 years, but maybe in North Carolina, maybe 10 years is a relatively short amount of time for fire hydrants to be painted, right? Maybe the paint lasts for 50 years, and so 10 years is relatively short, but not painted. So it's interesting to be able to see what the average is and then just go based kind of higher than that and how it intuitively did that. I didn't have to tell it to do that. It already knew to do that, which again, why I think Julius is such a phenomenal tool, right? Again, really cool tool. If I'm wearing the sweatshirt too, it's an amazing tool. So here we have, okay, this is pretty cool, right? So here's different clusters. Here we have it up here. Big cluster here, big cluster here, big cluster here. Each cluster represented by a different color. So cool. So let's go ahead and bring a different data set in. Let's see what we can do here at the different data set. Let's bring in some building data. So I'm going to close these ones off here. And let's bring in some building permit data. Again, same thing from North Carolina, from data.gov. A really cool site if you want to bring in some data and just kind of play around with it. And test out ChatGPT, test out Julius, test out these different AI tools that are out there with data and see what we can do. So let's go ahead and let's look at the landing page first. I always like to look at the landing page, see if I can edit this data a little bit down and focus on some things. So about 78,000 records. Oh my word. Cool. And I'm kind of thinking I'm going to bring the whole thing in, but I'm not going to do that. That'd be mean. Let's go ahead and bring in everything from, come on. Let's bring this in. I'm going to adjust this date here. Actually, let's go here, January 1st. And let's do this as 2021. And let's go from there to 2023. And do you know what? Let's go ahead and actually do this. Let's go back to 2019 and do, let's do January 2019 through 2023. That might be a cool way of doing it. Right? Here we go. Cool. This is a completed date, so I think that's pretty cool. Okay, cool. Here we have it. Here we go. And let's download only 37,000 records instead of having 78,000 records. But this will be a little easier, somewhat easier to manage. It's going to download here, and once it's all downloaded, we're going to go ahead and upload this into Julius. So I'm going to say I have building permit data I want to add to this conversation. I don't think it knows it yet. So cool. Even says to give it. Oh man. Oh, do you see this? Do you see this, guys? Wait a second. I gotta scroll in here so y'all can see this. I don't know how big I can get this because I want y'all to see what this looks like here. Come on. I might have messed this up. Let's try this again. Okay. Do y'all see that guy right there? Little clippy guy? That's pretty cool. Sorry. That's pretty cool. Nice little touch there. Nice little touch. I like those little things. Those little things are cool. Great job. Great job, y'all. Okay, sorry. A little distracted by that. Let's go ahead and bring in this building permit data now. I got distracted by the Clippy guy. The Clippy. Yeah, we brought Clippy back. The first AI guy back in the day. Nice little nod there. That is really cool. So let's go ahead and bring this in now. Permit applications. And let's say here it is. Okay, permit applications. Go to the file, understand the data. Help us determine how we can integrate and analyze it with the fire hydrant data. Take a couple looks here. Description, issue date, address, permit, project. So mapping permit locations along fire hydrants to see the proximity is one thing we can do. Analyze permit types and frequencies in areas of the older fire hydrants. Examining any correlation between the cost of projects and the age or condition of nearby fire hydrants. Let's do this. This might be kind of interesting, actually. Let's do this here. I'm not sure if we'll be able to do it, but I'm really curious. If we can do this, it'd be super, super interesting, actually. Okay, it's going to try to geospatial join based on proximity. That's going to be tough. We'll see if we can do this. That'd be pretty cool. And then data preparation, stat analysis, and things like that. And it looks like we're already having some trouble with this geospatial join based on permit and hydrant data. It's running some errors in the geospatial join, I think. Yeah. I try again, though. Man, if this works, y'all, I'm not sure what I'm going to do. I don't know. I don't even know if we can really do much with the spatial join or joining the stuff here. Okay, so there's some missing values here that is messing this up. For this, I'm just going to exclude them. Exclude those ones. Basically, what it's saying is there's some missing values in the year since painted column. And so for the sake of this, I think we just exclude it, right? And just see what we can do without them. That way we can see what happens here. All right, so it's looking through here. Still having some issues. And this is again why I like Julius, is because not only does it have Clippy, which well done, but it also is such an intuitive tool that it just is like, hey, let me try this, and doesn't accept failure. That's what I love about this. It keeps trying and keeps trying and keeps trying, and it's just I love this tool. It's a phenomenal tool. If you're not using this tool and you're doing any types of data analysis, you got get on this tool. And I'm saying that as it's like, hey, I can't do it. I'm trying to do that, but I can't do it. So I still think it's amazing how it just doesn't can't do it. Whatever, give up. Let's try some other approaches and see if we can do this. If not, we'll just kind of analyze the building permit data on its own. We might find some value with that too. I was hopeful maybe we can kind of merge the two together, but if we can't, that's fine too. If you want to find a really cool video on how we were able to merge things together, go ahead and check out the one I did within ChatGPT of merging those things and how we were able to merge some data together. It was a little more easier data set to actually merge together, like two different data sets that have property values on it. These are, I think, different because fire hydrants aren't necessarily tied to property values as building permit applications are. So a little easier to do that. But if you want to see that video, go ahead and click the link above and you'll be able to see what that looks like. So let's go ahead and see what we came up with here. Here are a few alternate approaches we can consider. To analyze the relationship between project costs and the condition of nearby fire hydrants. Revisit data cleanup preparation. Aggregate the data. Instead of looking at individual projects, aggregate project costs and hygiene conditions by geographical areas or time. Blah, blah, blah. So let's just go like this. Let's just look at the permit data as a standalone. So yeah, look at it independently. Okay, cool. Different categories here. It's really liking histograms right now. I don't know if that's a trend. If in April 2024, going into May, if histograms are the new or the trendy visualization right now, because it seems like everyone wants all the AI models want to do a histogram on something. I don't know, but it's cool. All right, interesting, I guess. I want something better than this, though. Let's see here. Let's look at distribution of project costs to understand the range and common values. Let's do this here. And look what we can do here. I'm going to turn on the advanced reasoning on this. Different tools, search the internet, plain mode, code. We're going default. We're going ChatGPT 4. We're going Claude. Let's run Claude and advanced reasoning and see what we can come up with here. So we can see there has a plan on the side over here, right? I analyze the distribution of project costs, identify any interesting patterns or outliers in the project cost distribution, wait for user input on next steps. That's the plan that it's going to give itself. So here we have it. We have, based on the histogram and summary statistics, there are a few interesting patterns and outliers in the project costs. Skew distribution. Project costs are heavily skewed to the right, with a long tail extending to very high values. Outliers. Maximum project is 136 million, 137 million running up, and much higher than the 75th percentile value of 27,500. Could be worth investigating these high project costs to understand the nature and the special circumstances. Concentration of low project costs. Histogram shows a concentration of projects in the lower ranges, particularly below 50,000. So let's see here. Let's go ahead and calculate and examine additional percentiles, i.e. 10th, 90th, to gain more insights into the distribution of project costs. Okay, here we go. 10% of projects cost $1,500 or less. 25% cost $4,500 or less. 90% of projects cost $163,000 or less. So here makes sense there. And that's going to create a box plot. Show me this. And here we have it. Let's see here. Have a cool box plot there. And let's say here, can you give me a graph of let's just grab the 40th percentile over the last 4 years. I'm just going to look at the date column to see that. What I want to see is, okay, is the 40th percentile, how has that changed? How is the 40th percentile back in 2019? And what is the 40th percentile in 2023? And how has that changed, right? It could be kind of interesting to see how that's changed there. It's going to use the issue date column as its metric, which is, it's fine. Just as long as we're consistent is all that matters. Okay, here we go. Try this. Relatively stable the last 4 years, the values ranging between 6,000 to 7,000. Slight increase in the 40th percentile from 2021, followed by a decrease in 2022. Overall trends suggest that 40th percentile project costs has not changed significantly in the past 4 years. It's very interesting here. I think it's really super cool. But again, the purpose of this video, the purpose of doing this is to show just how easy it is to bring in data and just ask questions and be curious and to see what we can do and try things out, try to push the limits of it. Right now, obviously, if I had a better data set, I probably could have done a geospatial join and done that. I know I could have, based on the success of a previous video I've done. So I know we could do the same thing. Just the fire hydrants aren't necessarily tied to geospatial locations. A little more tricky to do that. It's just even the fact that I didn't give up is just absolutely incredible that we kept trying, kept going, and achieved some really cool visualizations, able to map this out, able to create a cluster map of Cary, North Carolina. Like, how cool is that? And we got introduced to Clippy again. Haven't seen that guy in a while, right? So hope you enjoyed this video. If you did, again, please go ahead, leave a like, subscribe to the channel if you're not already subscribed. Appreciate all the support you all show. Thank you so much for it. And until next time, as always, be well.